480. So it's half of 397. So it's equal to 198.944. And finally, at gear E, okay, so the power is equal to 30 times 10 to the power 3. So torque at E is equal to 30 times 10 to the power 3 multiplied by 60 divided by 2 pi 480. So this is equal to 39 is equal to 596.831. Okay. So we know that this is power output, torque for the output, torque for the output, and this is torque for the input, right? Because gear E is connected to the what? To the motor. Okay. So now, how does this affect? Why do we say there is gear C and gear D, right? And we are ignoring gear G and H. Why that information is important? So from here, right? Let me shift over here. We can calculate the force acting on gear C, which is equal to torque of gear C multiplied by radius of gear C. That is why this information is important. It's the radius of gear C, radius of gear D, radius of gear E, and not the radius of gear G, H, and what? And the one attached to the motor. Okay, for this reason. So from here, we can calculate the, I got this wrong. Force of gear C is equal to torque of gear C divided by radius of gear C. I do apologize. Okay, not times. Come on. So the torque of gear C is 397.887 divided by RC, which is 60. Or 60 times 10 to the power minus 3. Okay, so 397.887 divided 60 power minus 3 is equal to 6631. Okay. 6631 or 6632. Okay, 6632 Newton. Okay, so the force acting on gear D, which is equal to torque at D divided by radius at D, is equal to 198.944 divided by 80, right? So this is 80. So 80 times 10 to the power minus 3. Okay. So 198.944 divided by 80 power minus 3 is equal to 2487. Right? 2487 Newton. And finally, the force at gear E is equal to 596.831 divided by the radius, which is equal to 160 millimeters, which is equal to 0.16. So this is equal to 596.831 divided by 0.16 is equal to 3730. Okay, this is the easy part. I like to elaborate first. This is the easy part. Okay, what is the difficult part of shaft design? Okay, what usually shaft design, there are commercial software for it. Okay, and when someone writes a commercial software for it, it means it's difficult for human to analyze such a design. Okay, so what is so difficult about it? Okay, so this information that we have calculated are critical. So we know the forces. We are also aware of the torque. Sorry, we are also aware of the torque. This set of information are critical, right? Why is it critical? One thing that we have ironed out already, based on this formula, right? We already more or less have the torque value. Okay, later I'll show you what do I mean by that. Next, we have to determine what is our my and what is our mz. Okay, and torque is easy because it's either going clockwise or anti-clockwise. Whereas moment, right, it's not so straightforward. It's all dependent on the direction of the force. Okay, you might say, Eugene, forces is also straightforward, either bending moment, smile phase, or set phase. Whether is it smiling phase or set phase, it dependent on which direction the force is applied on. Okay, now before we do that, let me highlight something really critical. Okay, let me get that image. Let me check anyone asking questions so far. No. Okay, let me get the image across. Okay, now I'm going to write out our transformation. Okay, draw transformation. So this is our x, right? This is our y, and this is our z. Okay, and I want to highlight this now, which I have not. Must take notice of the direction of the motor. Okay, I want you to take the direction. So you can see the direction of the motor is going this way, right? You can see that now. Now, why that is important? Okay, so now we're going to view the motor gear, okay, and gear E. Okay, I want you to take note of the motor gear and gear E. Okay, so I'm going to draw the view now. Okay, so this is Y, this is Z, this is rotation X. Okay, so I'm going to draw gear E. Okay, I'm going to draw gear E first. So this is our gear E, right? Okay, so this is our gear E. Okay, and this is our shaft AB. Okay, I'm not going to draw the gear attached, so I'm going to draw the motor gear. So this is our motor gear. Okay. So this is our motor gear. Okay. This is our motor gear. Right. So this is our driver. Right. So the driver, right, is and I want you to look at the point of contact is at the side, right? Okay. So it's pushing down this way. Okay. So this is the motor gear. So this is the force due to motor. Okay. Now gear E on shaft AB is also known as the driver gear. Okay. So the driver gear. Now some of you will ask me, Eugene, why the motor force is going down. It's because of the rotation of the motor. Right? If you look at the highlighted yellow, so this is the rotation. I think I will use a different, too many same color. This is the rotation of the motor. Okay. Now, gear E is known as the driver gear, right? Why? It will drive the shaft AB. Okay, it will. Why it's called? It will drive the shaft AB. Okay. So because it's the driver gear, okay, the rotation, we know that the rotation will also go in this direction. Yes, right? And then the force, right? The force applied is in the same direction of the motor. So this is the direction. I'll change color. This is the direction of gear E, right? So this is gear E in the Y direction. Okay, so the driver gear, okay, the driver gear force EY will follow the same direction as the motor gear, as you can see down here. So these two directions are the same. Okay, right? So now, this is the easy part. Okay, this is straightforward to to uh to understand. Okay. Now the next one that we are going to focus, the next one we're going to focus is we are going to now focus gear. Now before we go on, right? I will now we know this, so we know that this is the direction of EY. Right? Okay, that is the direction of EY. Okay. So the next one we're going to look at is we're going to look at gear D. Okay, gear D. So gear D and gear C. I'm going to draw gear D first. Okay. So consider, now we're going to consider again our have this diagram. I'll go slow, okay, because a lot of time students make this mistake. Okay. Now we're going to consider gear D. Okay. So again, we have to look at the shaft AB. So I still have to copy this whole thing. Come on.